Hey everybody, welcome to Practical Alchemy. Today's episode is going to be part 2 of my complete V-carving walkthrough. In part 1, I showed you how to create a file in Fusion 360, generate your toolpaths, and export them to your jump drive. In part 2, I'm going to be walking you through the machine setup and V-carve process step by step. So if you are new to V-carving or new to CNCing in general, this video is going to be perfect for you. In this video, I'm going to be running my Onefinity CNC machine with a Makita router. Now, it's very likely that your setup is not going to be the exact same as mine, and that's okay. The first thing that I want you to do before we go any farther is spend some time familiarizing yourself with your machine's operations, how to jog it around, how to input files, etc. Because once you understand your machine's specific inputs, the fundamentals of V-carving are the exact same, regardless of what machine you're using. Alright, so with the introductions out of the way, it is now time to prep our stock material. So the first thing that you're going to want to ensure when prepping your stock material is that the bottom and the top are completely flat, i.e. it's sitting flat on the workspace. If instead your material looks something like this, with a large bow in the center, you are going to have a bad time because even after you clamp it down, it's going to want to spring back up. The result is that you're going to have an inconsistent top Z height and you're going to end up carving deeper in areas than you intend to because the bit is going to go deeper into that piece. For this project, I found a nice piece of 3/8 inch project lumber in my shop and hit the front side with a quick coat of black spray paint just to make this V-carve pop a little bit more. Certainly not something that you need to do, but I think it adds to the final product. Next, it's time to start trimming up our stock to match what we had in our cam file. So I'm going to use the table saw to trim the depth to 3.5 inches, like I have in the cam file, but I'm actually going to leave the length a little bit long. Rather than the 12 inches that I have in our cam setup, I'm actually going to leave this workpiece at 16 inches. And I'm going to explain why a little bit later in the video, but just trust me, it's all part of the demonstration. With your workpiece trimmed to the correct length, it is now time to identify and mark the center point. And I want you to be very accurate when you do this. So make sure you grab your ruler and clearly mark that center point. Now, quick pro tip that you're not going to see in this video is use a piece of tape. That way you don't have a pencil mark on your really nice workpiece that you have to try to clean up later. And also it's going to be a lot easier to see than my silver pencil on black. So make sure you get that center point very clearly marked because that is what you're going to be using to define the 0, 0, 0 point moving forward. Next up, we need to remove the old bit from our router. So I always like to use a little foam pad just so the router bit doesn't accidentally fall and chip or dent itself. Then using your collet wrenches, you're just going to grab on, loosen, and then once the tension is broken, you're going to release the rest of the bit by hand. Once the bit's removed, I like to use a little bit of compressed air just to clean out the collet and make sure that we don't have any leftover sawdust. Then I do the same thing on the bit before I put it away. Now it's time to install our V-carve bit. So just slip it into the collet and you are going to push the red button to hand tighten it. And then you're going to release the red button and use the collet wrenches to do your final tightening. This is actually something that I've learned recently is that you are not supposed to use that little red button to tighten. It can break, so make sure that you're using 2 collet wrenches to do that and not tightening with your button. Next up, we are going to secure our workpiece to the bed. As you can see, I've got some lines etched into my bed that I'm going to use to very clearly identify the horizontal line. So I want to make sure that my workpiece is aligned to that. And now I'm going to clamp it in place. As you can see, I've got T-tracks in my work bed so that I can slide these clamps in. And then I'm going to clamp in from the edges. Now, as you're tightening your clamps, make sure that you're checking and double checking that alignment because you want to make sure that the horizontal of your workpiece is aligned with the horizontal x-axis of your CNC machine. If those things are not aligned, you are going to start carving at an angle, right? So if you're 5 degrees off from the axis of your workpiece, you're going to be 5 degrees off on your carve. So as you're installing those clamps and as you're tightening it down, just make sure that you're staying aligned with your x-axis. Once you've got those clamps tightened down, you want to just check your workpiece and make sure that it is secure and not sliding around on the bed. These CNC machines are very powerful tools, so they will throw a workpiece around if it is not secured properly to the bed. Now, there are a lot of different clamps out there and a lot of different clamping methodologies that you could employ for securing your workpiece to the table. The most important thing that I want you to consider, no matter what types of clamps that you use, is to make sure that you've got enough clearance around the outside edges of your tool path so that as your tool and your CNC machine and the dust boot are moving around the table, you're not going to run into a clamp. Because if your tool path has you running into the side of a clamp, it's not going to stop. It's just going to hit it and you're either going to break your dust boot or you're going to end up breaking your bit. A little trick that I recommend, especially as you're starting off to help you visualize this concept, is to create yourself a little paper offset gauge. That's going to be the size of your dust boot. It's going to have a center point around the center of your tool, and you could actually just use this little piece of paper to trace yourself around the outside edges of your outermost tool path, and you're just going to go around and double check to make sure that you have clearance in every single direction. And give yourself a little bit of peace of mind about where you're placing your clamps. With our workpiece secured to the table, the next step is to zero out the X and Y axes. In other words, we need to tell our CNC machine where in 3D space that center point that we marked is. So we're going to start by jogging along the X and Y axes, and as we start to get closer, we're going to move in smaller and smaller increments. Now, once you are in the general proximity of your center point, you are going to start jogging along the Z axis. And I want you to be very careful when you do this, because moving in too large of an increment runs the risk of burying this bit into your workpiece and ruining it. So as you get closer, I want you to move in smaller and smaller increments. And when the tip of your bit is just above the top of your workpiece, you're going to make your final adjustments along the X axis and the Y axis until the tip of that bit is right over the center of your marking. Now it's time to move over to the console, and you can see once I hit the set button, it is going to set my X-axis position at 0 and my Y-axis position at 0. As you can see, the Z-axis is still unset, and that is good. We are going to set that axis separately. So to set the Z-axis 0 point, there are essentially two different methodologies that you can employ. The first is the use of a pro block. To use a pro block, you are simply going to set it on top of your workpiece, and you are going to jog your bit over so that it's floating a few millimeters above. When you hit the Z Pro button, the bit is going to come down until it makes electrical connection with the block. It's going to come back up and do it one more time to confirm. Essentially what it's going to do here is tell the machine that the 0 point is that distance minus the thickness of the block. Pretty straightforward. Now, if you don't have a pro block, there is another methodology that you can use, and that is a simple sheet of thin paper. In my case, I am actually using tracing paper. So what you're going to do is you're simply going to place that piece of paper underneath your Z bit. Then you're going to come over to your console, and very slowly you are going to start to jog the Z axis down in the smallest increment that you can. All right, you're going to go down step by step, and then you're going to try to move the piece of paper. See if it wiggles. Come back to your console and do it again. Move it down, test the paper. And once we get a nice little bite on that piece of paper and a little bit of resistance, we know that that is our 0 point. So we're going to go back to our console, and we're going to hit the button to zero out our Z axis. Okay, very important. Once we have the Z axis zeroed out, I want you to jog your machine up. All right, start off very slowly just to make sure that you don't actually hit the wrong direction. All right, and then once you've got it up above the workpiece, I want you to continue to jog that Z axis up until you've got some nice clearance between your workpiece and the bottom of your V bit. Now it's time to set up your dust boot. Yours is probably going to look different than mine, so I'm not going to go into a ton of detail here, but essentially what you're going to do is position your dust boot, loosen the tightening knob so that you can drop it, and have the brushes rest gently on top of your workpiece. Then you're going to tighten it down, and you're good to go. Next, we're going to set the router speed. Remember, that is not set by the CNC machine. You need to adjust it manually to the right speed. And I actually use a piece of tape to prevent it from wiggling and changing speed over time. Working on a better solution, but a piece of tape will work if you have nothing else. There are three more very important things that I want you to keep in mind before you start your carve. Number one, I want you to make sure that this workspace is completely clear. There should be nothing on the table or in the path of your router before you start a carve. You can see I've got a clamp back here. The reason for this is because your router does not care. It can't see it. So you run the risk of it damaging the router, the table, and the workpiece. Number two, and I'm going to use this coffee cup as an example. Let's pretend this is our router. If you, for example, start off before your carve and home your router over here, and then you hit go on your toolpath, your router is going to wrap it into the side of this clamp and it's going to damage it, right? What your router wants to do is go from wherever it is to, you hit go, it's going to go to the first position on your toolpath. So you want to make sure that there's a clear path there. If there's something in the way of that path, it is going to slam into it. And again, your router doesn't care. It can't see it, so it will damage the router. Number 3, I want you to jog your bit up above your workpiece. All right, here's what can happen. If you manually zero your bit, it's sitting right on top of the workpiece, I need you to manually jog it up so that it can move freely. Why? Depending on the program that you're using, there may not be a command in the file to tell it to go up to the clearance height before it starts moving to the first position. And if it doesn't, what it's going to do is drag right across the workpiece to that first position. So here's what can happen. I did this carve a few weeks ago, and I did all of this beautiful carving, switched to my final edge cutting bit to cut the piece out, zeroed it out, and just let it go, and it dragged right across the top of the workpiece and totally ruined it. So I highly recommend going to your clearance height manually, at least until you're confident doing it in your CAM program. The last thing that we need to do before we start our carve is to double check everything, because let's be honest, there's a lot of steps and you are going to forget things. So let's go through our pre-flight checklist together. Number 1, is your router bit installed correctly and is it tight? Number 2, is your dust boot secured and is it set to the correct height above your workpiece? Number 3, is your piece tightly clamped to the table? Number 4, is your router set to the right speed? Number 5, are your clamps set outside of your toolpath? Number 6, is your workspace clear? Number 7, is your center point set correctly? Number 8, have you ensured that your router is not going to hit your clamps as it moves across the table to the first position? Number 9, have you jogged your router up above your workpiece? And last but certainly not least, have you connected your dust collection system? Congratulations, you have now completed your pre-flight checklist and are ready to carve. Okay, so there is one more very, very important thing that I need you to do before we actually start carving, and that is locate the emergency stop button on your machine. Make sure that you know exactly where it is and that you're comfortable pressing it. Look, even with the best planning, things can happen, right? Bits can break, you export the wrong toolpath by accident, somebody nudges the machine. So I want you to make sure that you know where this button is, keep your hand hovered above it, and don't be afraid to press it. If something's starting to go wrong, slam on that button and your machine will stop. This is so important. I'm going to repeat it one more time. Do not hesitate to push that button. It is way more important to keep yourself safe than to potentially ruin a workpiece. All right, let's start carving. The first thing that we're going to do is load up our USB drive with the cut file on it. Then we are going to scroll down our machine, browse to the correct path, and go down to find our first safety glass cut file. Open that file. It is going to load into our machine. And then once it's processed, we should be good to go. Now, before you hit that play button, I want you to make sure that you grab your safety glasses and your ear protection. I know I've said this a few times already, but this is a very powerful piece of equipment. So make sure you've got your ear protection on and your safety glasses on before we start cutting. Now it's time to fire up our dust collection system, turn on our router, and last but not least, we're going to hit go on our console. Then you're going to see the machine move to the first position and start moving down along the Z-axis as it starts to engage the workpiece. You'll see the router is moving up and down along the Z-axis to engage the bit as it moves along the X and Y-axis to cut across the workpiece. Now, I could provide color commentary over this entire cut, or we could just watch the machine do its thing for a few minutes. Okay, I am going to jump back in here because I want to explain something to you. If you remember back to the first video, I had you export the outer frame and the text as two different carve files. Now, I also told you that you couldn't export multiple toolpaths using the hobbyist version of Fusion 360. Turns out that's not exactly true. You can export multiple toolpaths as long as there are no tool changes in between. Now, I certainly could have gone back and re-edited the original video to cut that part out, but I think it's actually very important to keep it in to show you as a practical example that no matter how much you do this, and even as you continue to grow, you are still going to make mistakes, right? Things are going to happen that are not exactly what you expected. So that's why it's important to keep an eye on your machine while it's carving and make sure that you've got that emergency stop button nearby. Now, this is a pretty small issue, no harm, no foul, but a good example of why it's important to keep your eyes on your workpiece. And just over 90 seconds later, our carve is done. So I want you to now switch off your router. And before you move your workpiece, I want you to inspect it. Make sure you don't need to go back and do another pass. And then I want you to jog your router up along the Z axis to make sure that you've got nice clearance from your workpiece. And then I want you to jog along the X and Y axis so that your router is no longer hovering above that workpiece. I know that sounds pretty trivial, but I've certainly been in situations where I'm in a hurry and I don't jog the router out of the way. And as I've been removing it from the table, I've scratched it on the router a bit and completely ruined it. Now, before we unclamp our workpiece, we're going to want to inspect it, make sure everything looks good, make sure we don't need to take another pass with a V-bit to do some cleanup. Obviously, if you're going to do a bit change, you're going to do that before you unclamp your workpiece. But because this is the only operation we're going to be running, I think we are looking good to go. Now, before we unclamp our project here, I want to circle back to a concept that we discussed earlier in the video, and that is the size of our stock material. If you remember at the top of the video, I told you to cut your stock material to 16 inches in length. But if we think back to our cam setup, that stock material was only 12 inches in length. Why did we do that? Well, there's actually two reasons for it. Number one had to do with the clamps that I have on hand. I was concerned that with a 12-inch workpiece, I wouldn't be able to set my clamps far enough outside of my dust boot to not hit them. The second reason is because I want to use this as an example to teach you a fundamental concept when it comes to CNC. This CNC machine is very powerful, but it's also not very smart. It's only as smart as you are. All this machine cares about, all that it knows is what the X, Y, and Z 0 point is. It does not have eyes, it can't see your clamps, it doesn't know how big the stock material. This stock material could be 20 inches long, it could be 3 inches long. Your CNC machine does not care. It is still going to take that 0, 0, 0 point and it is going to make the rest of the toolpath movements based off of that. Now, this is a blessing and a curse. It's a blessing in that you can use this exact same toolpath on a much larger workpiece next time, or set it at a different spot on your table, right? As long as you set the 0, 0, 0 point correctly, the carve will run without issue. Now, this can be a curse because it is incumbent upon you to make sure that you fully understand this concept as you're setting up your toolpath, your workpiece, and as you're running your machine. At no point is this CNC machine going to raise its hand and say, "Excuse me, I think you have a clamp in the way of my toolpath here, so I'm going to stop before I hit it," okay? It's important that you understand that this machine is going to do exactly what you tell it to do, and it's not going to stop unless you stop it. I hope you're understanding the concept at this point, but just to be clear, the same principle applies along the Z-axis as well. Your machine does not care what the thickness of your stock material is. So for example, here I'm showing you a 1.5 inch thick piece of wood. If, for example, I was to set the 0 point at the top of this piece of wood, what my router is going to do is make all of its Z-axis movements, all of its V carves based off of that 0 point. If I'm using a thin piece of material and I set that to the 0 point, my Z-axis is going to move relative to that. If I set the 0 point there, at the top of my thicker material, those same Z-axis movements are going to be happening relative to that top surface. So, at risk of sounding like a broken record, I'm going to repeat this one more time because it is so fundamentally important to your success. Your CNC machine does not care about the size of your stock material. All it cares about is where you put the 0 point and where you told it to go from there via your toolpath. So while it is a good best practice to set your real stock material to the same size as your digital stock material, and fundamental for some more complicated carves, the more important thing to remember at this phase is that you are smarter than this machine, and it will do exactly what you tell it to do. Literally. Okay, with all of that out of the way, it is now time to jump back to our walkthrough where we're jogging our machine to a safe distance from our workpiece before removing it. Then we will release the tension on our clamps and remove our almost finished safety glasses tray. I say almost finished because we clearly have a lot of extra stock material on the sides that we need to get rid of. As you can see, I put some faint pencil marks on the sides to mark where I'm going to cut, as well as the pencil mark that I probably shouldn't put in the center. You can see why a piece of tape would have been a better decision, which would have required less cleanup work. Regardless, we're going to take this over to our miter saw and cut off the extra stock material on either end. Then I'm going to hit it with a quick coat of spray-on polyurethane to protect the wood and give it a nice shine. And last, but certainly not least, it is time to bask in the glory of our first successful V-carve project and our new and improved shop safety standards. And that is going to do it for today's video. I really hope you enjoyed it. I hope you learned a lot. If you did, hit the like button. If you had any questions or follow-up that you'd like to see in future videos, put those in the comments below. And as always, hit the subscribe button so you can stay up to date as I release new content. Thank you so much for watching, and I'll see you in the next one.